Which computer am I on? This one. Okay, so for the circuit below, starting from Q1 equals 1, Q 0 equals 1, show the sequence of Q1, Q0, and F values for 5 consecutive clock cycles after that starting point with B, that's the input. If you can't see it here on the screen, that's B, with B equaling 1, 0, 1, 1, 0. Okay, so we have, and I should have drawn this. Yes, okay. So we have Q1, oh, it says up here Q1 and Q0, but I've got Q1 and Q2 in my diagram. Q1, Q2, Q1, Q2, B, F. And we're starting with both of these equaling to 1. So that means that when we start, Q1 is 1, and Q2 is 1. And the clock is going into both of these flip-flops, so the clock is the actual clock. Sometimes you might have something else feeding into the clock, and then that flip-flop only operates on the positive clock edge when the clock goes from 0 to 1. Speaking of clocks, how did the lab go this week?
It was pretty easy. It wasn't too bad.
Good? Any comments from the Zoom people? This is why I don't like teaching on Zoom. Yeah, okay, all right. Okay, so B has the values 1, 0, 1, 1, 0. Okay, so B is 1 when we start. And so we have 1 going into the T flip-flop. And if you recall, what a T flip-flop does is for a T flip-flop, if it's 0, you have no change. And if it's 1, it toggles. And by toggling, it means it goes back and forth. It takes the complement. And so the input is 1, so it's going to toggle. And so the next output for Q2 is going to be 0 because that will toggle. And then for Q1 was 1, and that value, my internet connection is unstable. How can that be? This is edgy wrong. Okay, so Q1 is 1, and that's feeding back into an OR. The OR of 1 and 1 is 1, and that's going into a D flip-flop. And a D flip-flop, Q follows D. Whatever D is, that's what Q is. So Q1, second time around, I'm going to cross it out even though it's not changing. It's going to be 1 as well. And F is the AND of Q1 and Q2. The AND of 1 and 0 is 0. Okay, so now we're on the next clock cycle, and B is 0. And so our input into the T flip-flop is 0, and a 0 into a T flip-flop means no change. So Q2 is going to remain 0. Now going into Q1, my B is 0, Q1 is still 1, the OR of 0 and 1 is 1. For a D flip-flop, Q follows D, and so that's 1. And the AND of 1 and 0 is 0. Now, like I said, these are modified problems, so I have the I've done these problems before, but I don't have the solutions in front of me. So if you see me make a mistake, I don't have something that I'm checking it with. And so if you see me making a mistake, please just holler out, because I probably have made a mistake and I would want to fix it. Although I am printing something out right now that I can use as a guide.
Can you say what a D flip-flop does again?
I will. Let me get these. Let me get this, and then I will tell you about a D flip-flop. Okay, so the question was asked here about a D flip-flop. So let me just remind you about the different flip-flops. We have T, D, we have J, K. So a T flip-flop, you would have your T input, you would have your old Q, and you have your new Q. So our possibilities are 0, 0, 0, 1, 1, 0, and 1, 1. So when T is 0, Q doesn't change. So that's 0 and 1. When T is 1, Q toggles, so it would become 1 and 0. For a D flip-flop, you have your D input, you have Q old, Q new, 0, 0, 0, 1, 1, 0, 1, 1. Q follows D, so it doesn't matter what Q old was. Q new, the next value of Q, is going to be the same as the old value of Q. For a JK flip-flop, you have J, K, Q old, Q new. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So when J and K are both 0, you have no change in Q. When J is 0 and K is 1, I believe that's a reset. Does anyone remember? I'll double check this at the break. I can never remember which is set and which is reset. I believe when K is 1 and J is 0, that's 0. And when J is 1 and K is 0, that's 1. And when they're both 1, it's a toggle. J 1, K 0. Reset. Yeah, K is reset. Is that what I did? Yes, that's right. Okay. All right. So the D flip-flop is just whatever the input was.
So JK only uses Q old whenever they both 1. So it toggles.
No, it uses Q old. No, you're right. Yeah, it only uses Q old when they're both 1. Yep. Yeah.
And with the T flip-flop, it only toggles once. The Q old is a 1.
No, it toggles whenever T is 1.
T
So
1.
toggle means it's the opposite of whatever it was before. So if Q before was 0 and T is 1, it becomes 1. If Q was 1 and T is 1, it becomes 0. Okay, so now on to our next input. So now we have B is equal to 1. So I'm going to erase the previous stuff that was on here. So now we have B is equal to 1. Q1 was 1. Q1 was 1. Oh wait, no one told me that I was not feeding Q1 into this OR gate. I'm feeding the not of Q2.
You don't still have it right there?
I might still have it right, let's see. I was not feeding, so I thought I was feeding Q1 into this OR. Let me go back and check this, hold on. So when B was 1, and Q1 was 1 and Q2 was 1, we would have the not of Q1 would be 0, and
It's the not of Q2.
it's the not of Q2, yes. Let me go back and do this. Let me just start from the beginning. Okay, all right, so let's check this out again. All right, so they start with both 1, B is 1. B is 1, so the not of Q2 is 0, but B is 1, the OR of 0 and 1 is 1, so Q1 is 1. B is 1, so we have a toggle, so Q2 was 1, it's now 0, the AND of 1 and 0 is 0, so that is the same. So we still have one, 0, and 0. Okay, and then when B is 0, Q2 remains the same. The not of Q2 is 1. 1 or 0 is 1. And Q1 will be 1. The AND of 1 and 0 is 0. So yes, it is still correct, but I just got lucky. Okay, so now B is 1. So B is 1. So T toggles. Q2 was 0. Now Q2 will be 1. But Q naught, it's referring to the previous value. It's not after I've changed it. It's what it was before. And what it was before was 0. And so it's still 1 up here at this OR gate. And 1 and 0 is 1. And so Q1 will be 1. And this time 1 and 1 is 1.
Can you explain that again?
Yeah, so when I'm looking to see, so I'm on this clock cycle right here. And when I start this clock cycle, I had the values from this row. So Q2 was 0, Q naught was 1. So I have a 1 right here when I start this clock cycle. So I don't change Q2 to 1 and change Q2 naught to 0 before I calculate what Q1 is. And so I still have a 1 here. B was 1. 1 or 1 is 1. And so I get Q1 is 1, but Q2 is now 1 because it was the toggle. Yes?
So if you were to set this up like drawing values, you would have B was a 1 right here going into it, and then the previous state of Q2 was a 0, so you'd have a 0 here and then a 1 here at the Q naught.
Yes.
The 1 or the 1 is a 1, so then Q1 is a 1.
Yes.
And since Q2 previous was 0, you have a 0. Then
Yes.
it'd be 1 and 0, and you'll get.
No, it was 1 and 1,
It was
wasn't
1
it?
and 1.
No, it was 1 and 0. You're right. So it should be 0.
Okay.
Yeah. Was that your question? Okay, I'll start over on this clock cycle. So let's check this clock cycle again. All right. So as we start this clock cycle, B is 1. When we started, we had the old values. Q1 was 1, Q2 was 0, which meant Q2 naught was 1. So this one is over here. Now we're going to get our new values. 1 or 1 is 1, so Q1 is 1. 1 is going into the T flip-flop. That means it's going to toggle. So Q2 will become 1, Q2 naught will be 0, but my output F is Q1 and Q2, and that is a 1. Yeah, that is a 1. That is a 1. 1 and 1 is 1. It is a 1. Because it's this one is our new value. F does go with the new value.
Okay.
Yeah.
Oh, okay.
Yeah, F does go with the new value. So this became 1, this became 0, this is 1, so F is 1. So it's the inputs to the flip-flop that use the old values, but F uses the new values. Okay, so now, and these values will all be in red. Okay, so B is 1. Our old value for Q2 was 1. So our old value for Q2 naught was 0. So now I have a 0 going into this OR gate. 1 or 0 is 1. So Q1 will be 1. A 1 is going into the T flip-flop, so it'll toggle. So this will become 0, this becomes 1. 0 and 1 is 0. And now for our last clock cycle, and I will use light blue. B is going to be 0. We're going to use, it's our old values that we're using for going into the flip-flop. Our old value of Q naught is 1. So I have a 1 or 0 becomes 1. So Q1 is still 1. Q2 toggles, or is it 0? No, Q2 stays the same. Q2 stays the same, so it's 0. And 1 and 0 is 0. You know where my office is, right? Would you go run and get what's on the printer for me and bring it back? Okay, so I know that I'm scatterbrained and messed that up like 20 times, but are there any questions on it? And okay, our Q1, and so, okay, all right. Yeah, if any of you, so, I don't know who this is because I don't know what this stands for. This person doesn't have a mic, so he or she has to chat. But some of you do have working mics, and so if you see something in the chat, just holler out. There's something in the chat. If you don't want to say what it is, that's fine, but let me know. Okay, question?
So, whenever we have the flip-flop, the only thing we have to worry about is the input D.
Say that again?
So whenever we have like a D flip-flop, the only thing we have to worry about is the input D, where it's 0 and 1.
When you're saying D?
D.
Yes, correct.
Right.
Yes. This is useless. Okay. All right. I am probably going to redo this one or do another one like it. Okay. What that is. All right, problem 2. All right, draw the circuit corresponding to the Verilog module below. All right, so I want to give you some tips for how to do this because it may seem overwhelming, but if you see something like this, it's likely to have a similar sort of setup. So first of all, when you see a Q in there, that means that you're probably going to have flip-flops, and it's probably going to be a register, especially when you see a for loop. And you can have an idea as to how many flip-flops you're going to have by looking at the parameter. That's likely going to tell you how many you're going to have. Can't guarantee it, but it probably is. So we're probably going to have 4 flip-flops. And then we get more of a hint on that when I see this. It says reg n-1 to 0 q. So n is 4. So that's saying 3 to 0 q. That's a vectored signal. That tells us that we have a q0, a q1, a q2, and a q3. So we have 4 values of q. So now we're pretty sure, yeah, we've got 4 flip-flops. The integer j is just used for the counting. It's just used for the for loop. And output b, that just means it's going to be an output. So we can be pretty sure when we start this, and so this is going to be just like a hint for you to get started on your test, that we're going to have 4 flip-flops. So you can always do this even if you're not sure what else to do. Draw your flip-flops, and you would usually use D flip-flops because those are the ones that make sense to use, because they're the ones that have the same output as the input. You'll have a clock. You can go ahead and draw your clock in. And I'm going to label these 3, 2, 1, and 0. And that tells me this output is Q3. This output is Q2. This output is Q1. And this output is Q0. And I did all of that without really even looking at the rest of the code. I'm pretty sure that this is going to be useful. Now, the other thing that I can do is I can look in my for loop, and if I have an if, I'm probably going to have a multiplexer, because a multiplexer is a good way to implement an if. And so I am probably going to have a multiplexer associated with these flip-flops. So I'll put my multiplexers in. I might not use them, but I'll go ahead and put it in for now. Yes?
Are multiplexers, they're used to make decisions?
Yes.
Okay.
Yeah. We'll use it. We're using it for our if. And because if you look at our code, it says if y, q is something, else q is something else, it's this multiplexer is going to be determining what value we're giving q. And so when you do this, you're going to have the output for your multiplexer is going to go into the input of your flip-flop. And you put the value, so if in this case it says y, so in this case it'll be y. So if y, you put the value if y equals 0 into the 0 port of the multiplexer, and you put the value, and when I say value, I mean the value of q. The value of q, put the value of q if y equals 1 into the 1 port of the multiplexer. So let's see what I mean by that. So if we go back and look at our code, we have a for loop, and it's saying for j equals 0, j less than n minus 1, j equals j plus 1. So that means I'm going to start with j equal to 0, and then I'm going to do 1, and then I'm going to do 2, and that's where I'm going to stop, because it has to be, j has to be less than n minus 1. N was 4, and n minus 1 is 3, and so I just have j equals 0, 1, and 2. So that actually tells me that I really don't need this multiplexer for my number 3 flip-flop, because the for loop only goes for 0, 1, and 2. Yes?
Sometimes you can have a like a equal, less than or equal to as well.
Absolutely.
Okay.
So yeah, you could. So I did that on purpose. I actually knew where this one was going, so I drew it and then I went back and erased it, because usually you actually end up using all of them, but in this case we didn't. Okay. And now it says if y. So this thing that's inside the if, that's going to be what goes into the top or the bottom of the multiplexer. That's the thing that makes the decision. And so y, that one goes into the multiplexers. And if y, that's the same as saying if y equals 1. So if y equals 1, q of j becomes equal to the naught of qj plus 1. So let's just start with 0. So that would be q of 0 becomes equal to the naught of q of 1. So let's get that. So, and this was if y equaled 1, so it goes into the 1 port of the multiplexer. So q of 0 becomes equal to the naught of q of 1, and that goes into the 1 because it was if y. So if y, q of j becomes equal to q of j plus 1. So we did 0, now q of 1 would become equal to the naught of q of 2. That's supposed to be a NOT gate. And q of 2 becomes equal to the naught of q of 3. So I did each of the ones in my for loop. I did 0, 1, and 2. I made them equal to the naught of the one bigger than it. That was if y equaled 1. Then the else is if y equals 0. So if y equals 0, it equals q of, so let's just look at q of 0. Q of 0 becomes equal to the and of q of j, q of 1 and x. Well, I don't have an x yet, so I need to have an x variable. So we'll draw another wire for x. So I'll have x right here. And I'm going to have the and of Q1 and X going into the 0 of the multiplexer for Q0. The AND of X and Q2 going into Q1. And the AND of Q3 and X going into Q2. So now I've taken care of my for loop. And the last thing is outside of the for loop, it tells us what Q of 3 is going to be. So Q of n minus 1, that's Q of 3. That's going to be A. So I just have yet another variable, A, and that's going into Q3. And then outside of that, I have assign B equal to Q of 0. So I'm just going to make this equal to B, and I'm done.
You think there's a chance we're gonna have to write Verilog code on the exam?
I doubt it, although I do have one. I do have practice with that. Does anyone remember from the old test if there was any writing Verilog on the old test?
I don't think
I can look real quick. I didn't put it.
Okay, yeah. Why don't you look real quick and see? Yes.
I have a couple of questions.
Sure.
Why did we do Y on the top of the multiplexer? Why not the bottom?
It could be the bottom.
Could be.
Yeah. It just depends on how your schematic is drawn.
Alright, and also, how do we decide that Q was going to go into the 1 of the multiplexer, and that X was going to go into the 0 of the multiplexer? Like the X in AND goes into 0, and then the Q not.
Okay, so that is from the if statement. So if Y, so that's if Y equals 1. So that line tells me what goes into the 1. What goes into the 1 is the not of the one bigger than it.
So how do we know that goes into the 1?
Because it says if Y, and if Y is the same as saying if Y equals 1, and Y is our select for the multiplexer. So Y tells the multiplexer what to choose. So if Y equals 1, it's going to get what's going into the 1 of the multiplexer. And
So the reason we know if Y is equal to 1 is because it's first?
no, just because it says if Y means the same thing as if Y equals 1.
Okay.
And else means if Y is not 1, then it's 0.
Okay. Alright, so
Other questions? Okay, then the next part says beginning with state 0, 0, 1, 1, what are the next 3 states and value of B if A equals 0, X equals 1, and Y equals 1? So A equals 0, X equals 1, Y equals 1, and Q is 0, 0, 1, 1.
Someone in the chat asked, what does J plus 1 mean?
Okay, you are my hero for chiming in and asking, letting me know that. Okay, so right here in the for loop, this is just like a for loop in C++, which I believe you've all had, except Verilog doesn't have a plus plus. So J equals J plus 1 means each time through the for loop, J goes up by 1. So the first time through the for loop, J equals 0. And then the next time you add 1 to it, it equals 1. The next time you add 1 to it, it equals 2. The next time you would add 1 to it, it equals 3. But when it equals 3, that's no longer less than n minus 1, so you're out of the for loop. Did that answer the question? And when do we use reg? So you use reg whenever you are assigning a value within an always block. So if you look at this code, qj, we're giving it the value in an always block. So q is defined as a reg. B we give it a value outside of the always block, so it is not a reg.
What was the phrase you just said? You said when assigning, or use reg when assigning.
Oh, when you assign a value inside an always block. So if it's inside an always block and you're assigning a value inside an always block, it needs to be defined as a reg. Yes?
So why does X not need to be in a reg since it's in the always block?
Because we're not assigning a value to X.
Okay.
X is an input.
Okay.
So we have Q when it's you're assigning a value to a variable when it's on the left-hand side of an equal sign.
So
And
you
X
only,
is always on the right-hand side.
So you only register outputs essentially, or like
Yes.
okay.
Yes. Or things that are changing, because I mean the Q's aren't actually outputs here; they're just regs. But but basically yes, they're things that you're changing. They're not inputs. Okay, so if it says Q is 0, 0, 1, 1, that means that Q of 3 is 0, Q of 2 is 0, Q of 1 is 1, and Q of 0 is 0. Now, it's telling us that Y equals 1. And since Y always equals 1, we only have to worry about the part in the for block that said if Y. And the part that said if Y said Q of J equals the not of Q of J plus 1. If Y was changing values, we'd have to see what Y was each time. But it's not, it's always 1. So Q of J is always going to become equal to the not of the one before it. So how many clock cycles did I say? 3 states. Okay, so Q0 becomes equal to Q1, so it becomes 1. Or the not of the one before it, so it becomes 0. Q1 becomes the not of Q2, so it becomes 1. Q2 becomes the not of Q3, and so it becomes 1. Q3 was always made equal to A, and since A is 0, it'll be 0. So the next state, Q0 will be 0, because it'll be the not of Q1. Q1 will be 0. Q2 will be 1. And Q3 will still be 0. And on the next state, Q0 will be 1. Q1 will be 0. Q2 will be 1. And Q3 will be 0.
Can you run through the last two again?
Yes. Okay, so each time, every time Q0 is going to become equal to the not of Q1, Q1 will become equal to the not of Q2, and Q2 will become equal to the not of Q3, and Q3 is going to equal A. So A, we were just told A is always 0, so Q3 is always 0. Q0 is going to be the not of Q1, so the not of 1 is 0. Q1 is going to be the not of Q2, and Q2 is going to be the not of Q3. So then on the next one, Q0 is going to be the not of Q1, Q1 is going to be the not of Q2, and Q2 will be the not of Q3.
Okay.
And then the last one,
Following suit with that.
same thing.
Okay.
All right? Other questions? All right. Go on to problem 3. We're going to draw this. Did you find out if it had any?
No, it's just drawing.
Just draw it? Okay. So we'll draw one, and then I'll come back it won't take long to write the Verilog code, so I'll go ahead and do that, but I doubt, you were the one who asked that, right? Yeah, I doubt you would have to, but it's always possible. Okay, consider a 4-bit register using D flip-flops labeled D3, D2, D1, and D0. Okay, so just like what we did just a minute ago. That has serial input left 1 and serial output right out. Serial means it's just going in, it goes one at a time, and so when it says serial, you're just going to be talking about just the one value coming in here and the one value coming out here. So serial input left in and serial output right out. If the variable named signal is 1, the register should shift values right using the serial input left in as the input for register 3 and the serial output right as the output for register 0. Okay, so actually those right out is going to stay, left in is going to need to be in a multiplexer because it's an if statement. So it's an if statement, and so we're going to have signal up here. And we need, and this is like the 5th time I've used this question, and every time I realize it has a mistake in it, and I fix that mistake, and then the next time I use it, it has another mistake in it. But, so your multiplexers are always inputs into the flip-flops. Okay, the register should shift values right. That means that 3 goes to 2, goes to 1, and 0 goes out. So 3 goes to 2, 2 goes to 1, 1 goes to 0, and 0 goes out.
Just want to double check. You get the multiplexer from the if statement, right?
That is correct. Yep.
Okay.
Yep.
Thank you.
The if statement tells you the multiplexer. If for some chance you had a case statement, which I've never seen on a test, but you would just have a, like you had 4 possibilities, you would use a 4-to-1 multiplexer if you had a case instead of an if. Okay, and then it says we have parallel input W03. That just means that just like this output was Q3, Q2, Q1, and Q0, I also have a W that has 4 values, W3, W2, W1, and W0. And it's supposed to be the, let's see, if this variable name signal is 0, the register should load the AND of WI and QI into the ith register. So let's see what that is saying. So it'd be the AND, let's just say for I equals 0. It'd be the AND of Q0 and W of 0. So, and that is what's going to go into the 0 of the 0th multiplexer. So we're not getting it from the one before, the one after, we're getting it from itself. So I'm taking the and of W0 and Q0, and that's going into the 0 of the multiplexer. And then I'm taking the and of W1 and Q1, and that's going into the 0 of the 1 multiplexer. And then I'm taking the and of Q2 and W2, and that's going into the 0 of the 2 multiplexer. And finally, I'm taking the and of
Where does the
Q3.
W come from?
It's just an input. It's not coming from anywhere. It's just another variable. Rather than giving you 4 variable names, we're just calling them W0,
So
W1,
instead of
W2.
like one solid wire, it'd be 4 different inputs.
Yes. You could, if you wanted to be super fancy, draw a wire that had 4 branches, and that could be W0, W1, W2, and W3, because that's how it actually really works. So you have 4 wires together and you're just using one of each one. But I didn't want to draw that. I mean, this was already plenty messy enough. And then we're going to go ahead and do the Verilog code for this, because even though you don't have to write it, you do have to read it, and so knowing how it works will be helpful. So module problem 3, and our inputs are W, signal, right out, left in, and we said that Q was an output, so I'll put that here. And
There's another question in the chat.
thank you. Is there no cloud? There should be a clock. Thank you. Yep. And that's always something that you can do if you're stuck on the test and you don't know. I don't know. You can always draw in the clock.
Does it matter the order for the things in the parentheses? For the
You mean if I do 3, 2, 1, 0 or 0, 1, 2, 3?
No, like it says module, like parentheses.
Oh, no, it doesn't. It doesn't. Which would mean I also need clock. Except I'm not using the clock in, yeah, I am. No, I'm not. I'm not using the clock in this one. Okay, so we'd have input signal left in, output right out, input 3 0:3 W, output, is it output reg or reg output?
I think it's output red.
Output reg 0:3 Q. Oh, we do want the clock. Clock. Always at pos edge clock. Begin. So let's see, we've got 4 flip-flops, so I'll put parameter, I'll just use the number 4. I'll put in integer j, and I won't use that in, I'll just use 4. So I'll have 4 j equals 0, j less than 3, j equals j plus 1, if signal q j becomes equal to, what did we do if it was 1? It shifted values right. Qj equals qj plus 1. I actually need if signal begin, because we also had, this was only if it equaled 1, we had q 3 becomes equal to left in. Else begin q j becomes equal to q j and WJ. And then this really, I could have another, I told you that I realize I do something kind of weird every time. It's weird that I'm doing Q3 all by itself, but that's because it's not in the for loop. I'm just doing it separately because it's not in the for loop. Q3 becomes equal to Q3 and W3. And so that gets done like every time, which is not the best, but it's just how I'm doing it. And yes,
Why did you have to hard code Q3?
because it's different than the others. It's doing something different, and it would be best if I did it in a separate if and not inside the for loop, but I'd already committed this.
Okay.
Yeah.
But you could do it before the for loop if you wanted.
Mm-hmm. Yeah, I could do it outside of the for loop because here I'm recomputing it every time I'm going through, which is kind of a waste of computing, but I also didn't want to waste time.
Right,
So
yeah.
Okay. If else, and I think that's it. Oh no, I need. No, that's it, right? So end my always block and end module. Okay, so I can tell from the faces that I can see here that people are getting restless. We're going to take a 5 to 7 minute break, and I'm going to switch computers and start saving this and uploading. And then in 5 to 7 minutes, we're going to come back and start over again. Not start over, do the next two problems.